Okay, so welcome to part 4 of natural language processing in Python. So before we dive into this video, I just want to mention, as I usually do for every video in this series, there is an accompanying blog post which I will link to in the description below. So if you want any more details on the content of this video or any of the other videos that we cover in this series, there's a blog post for each video in the series. So that will elaborate a little bit more on the content within. And of course, as always, as well, for all the videos on my channel, there's always an accompanying GitHub link where I host all of the code that I use in my videos, so that way you don't have to just type everything out by hand. You can just go to this link, which will also be in the description below, and just copy and paste the code, and away you go. So I'm just going to move that over to the side, and let's get started on the subject of this video, and that is WordNet. So we're going to go over the resource WordNet, which NLTK allows us to access. And this is a really useful little tool that will be very handy for various natural language processing content. So just very quickly, if you're not familiar with what WordNet is, there's a Wikipedia link that I'll provide here. So just go over to that link and read up a little bit more about it. Very briefly, according to Wikipedia, WordNet is a lexical database for the English language. So it groups words into sets of synonyms, so words that are different but have the same meanings. And these groups of synonyms are called synsets. And they provide short definitions and usage examples and record a number of relations among these synonym sets and their members. So that definition might make more sense as we go along here and actually play around with the WordNet interface that NLTK provides to us. So it's really a great resource, and if you want more information on WordNet itself, there is this link here, which is the official WordNet website. So it's associated with Princeton, and it's just gives you a little bit more information that might not be present in Wikipedia if you want to read up more on that as well. So let's take a look at an example as to why, I guess is how to best use the WordNet resource, one of the ways we can use it. So let's consider the following two sentences here. So the first sentence here is this sentence that says, I learned natural language processing by resources found on the internet. And then the next sentence down is almost identical. I learned natural language processing by resources found on the net. So these two sentences are identical with the exception of the last word, where in the first one it's internet, and the second one it is net. So even though we changed one word, both the meaning of both of these sentences is identical, and that's because the words used in each of these sentences are synonyms of one another. So we can determine, so remember, a synset, as the definition for Wikipedia states for WordNet, a synset is a group of English words of synonyms. So it's basically just a collection of synonyms for a given word. So if we want to determine, for instance, what are the synsets, the collection of synonyms for a given word, we can run that using the WordNet module. So I should also mention that what I'm doing up here on line 23 is I'm importing the WordNet module. So I'm just importing from NLTK.corpus, importing WordNet, and then using this little modifier here, this WN. This will just be a quick way for us to manipulate and refer to WordNet instead of typing out WordNet every single time. So anytime we want to access this library, we can just type in WN dot whatever, and that will give us access to the functions that WordNet provides to us via NLTK. So back to line 35 here, what we're doing here is we're printing out all of the list of synonyms or the synsets of the word internet. So let's go ahead and write that and give that a run. So let's see, let me just Right, so I'm just going to go ahead and run this file here. And if we run this, then we should see that this gives us a synset here. So it's a synset object, and there's something that says internet.n.01. So this particular form will be something we'll see a lot in WordNet. It's the word itself, .n, which is in this case referring to a noun. And then this is the first occurrence of this thing. So let's go back and we'll comment this out so we don't see that every time. So as I said here, the internet.n.01 is a synset for the word internet. So if we print that out, if we expand upon that synset, we'll see all of the synonyms for the word internet. So let's go ahead and do that. So what I'm doing here is I'm saying wn.synset. I'm giving it the name of the synset that we obtained from the line of, I guess, this line over here, line 35. So I'm saying give me the lemma names of this synset. So the lemma names, when I say that, it's really just the name of the synonyms in this set. So let me go ahead and write that and print this out. So WordNet says that the synonyms of the word internet are net and cyberspace. So those are a few of the synonyms of the word internet. So that's what I'm saying down here in this comment. And we can extract a little bit more information from this as well. So in addition to just printing out the synonyms, the synsets, we can also determine what is the definition of a particular synset. So when we printed out the synsets of internet, there's only one entry. But for certain words, there could be more. Indeed, we'll see ones where there's more entries. And we want to make sure that the usage of that word that we're looking at is the one that we intend to use. So let's print out the definition of this, and then I'll show you an example as to why it might be different for words that might mean different things. So let's go ahead and print out the definition of this version of the word internet. So if we do that, we get this definition here: computer network consisting of a worldwide network of computer networks that use the TCP/IP network protocols to facilitate data transmission and exchange. That sounds about right for the word that we're looking at there. So let's go ahead and comment that out. In addition to printing out the definition of a word in this, which is a synset, we can also determine what examples are. So for instance, we can say print out the synset, the examples of the synset for internet.n.01. So if we go ahead and do that, in this case, what we'll see is we'll see an empty list. So for certain words or for certain synsets, there may not be any examples. And if there are any examples, we'll see this empty list here. So let's take a word that there will be examples and definitions for, and the list in this case will be populated. So let's consider let's determine what the synsets are for the word car. So let's first of all go ahead and print that out. So before with internet, we just saw one synset. We just saw synset internet.n.01. In this case, we see a few different types of things for cars. So we see cars over here, and then the last one here is cable car. So the definitions for each of these synsets in this set of synsets is going to be slightly different, because each of these is sort of a different interpretation of what the word car might mean given the context. So let's go ahead and just refer to the first synset of the list of synsets that we saw previously just now, and that's probably going to be the type of car that we're after. It's probably usually they're grouped in terms of kind of the most common usage to the least common usage. So what I'm going to do here is I want to print out the examples or an example sentence for the first set of synsets for this car.n.01. So let me comment this line out, write that, and go ahead and run this. So if I run this, we'll see he needs a car to get to work. It's an example sentence. Probably means exactly the type of car that we're thinking of. In fact, we could also say print wn synset car.n.01, and then let's just do the definition. We'll just print that out as well. Let me comment out the example there, give that a run. So the definition for the first one is a motor vehicle with four wheels, usually propelled by an internal combustion engine. Sounds about right for the car that I'm thinking of. There were a few other synsets. So what happens if we, let's see, let me go ahead and print out this thing again. Let me see what the list of synsets are. So there's N01, 02, 03. They're all nouns in this case, but there's different types of things. So let's go ahead and see what the definition is for the second set of synsets here. So let's go ahead and change this 1 to a 2, and let's see what the definition of this is. So let's go ahead and run this. Let's see. So I put in 22 instead of 2. That would be the problem. Let's go ahead and run that again. Right, so the definition of this one is a wheeled vehicle adapted to the rails of a railroad. So it's some other type of car. This could be like a train car, right? But it's probably not the type of car that, at least in this example, I care about. We can also, let's go ahead and take a look at what the third definition there is. So running that, it says the compartment that is suspended from an airship and that carries personnel and the cargo and the power plant. Okay, interesting. So there's different types of meanings for the word car, and each of these has its own synset associated with it. So I'm just going to go ahead and delete that. Let's go ahead and comment that out. Let's see, so we can also, just like we have the synsets, we can also obtain the corresponding lemmas for each of the synsets. So let's go back to the internet synset. So recall this is the name of the first and only synset for the word internet. And if I do .lemmas, what we'll see there is a list of all the lemmas. So these are the lemmas of each of the terms internet. So this one corresponds to the term internet. This one is .net, we see that, and then cyberspace. So for instance, if I go here for every lemma, so let's just say that we do it for internet.n.01.net. If I want the corresponding synset of that lemma, I can just run this command here, and that should give me net. Or rather, it should give me the synset that corresponds to the list of internet, net, and cyberspace, which is this synset right here. Let's go ahead and comment these out. And before we go on to kind of, I guess, more uses of distinguishing words, so we're actually going to build up here to figure out how we can actually distinguish, or how we can quantify the similarities between two different words. Before we do that, I'm going to talk about two different natural language processing terms, one of which is a hyponym, and this is a word with, let's just give the Wikipedia definition. It's a word of more specific meaning than a general or subordinate term applicable to it. For example, spoon is a hyponym or hyponym of cutlery. Okay, so that's kind of a maybe not a very clear definition. Let's take a look at an example, and I think it will become more clear if that definition was a little bit hard to follow. So let's go ahead and start off by just getting the synsets of the word cat. Let's print those out to the screen and see what we get. So we'll go ahead and run this, and we see a few different synsets. Again, these are usually grouped in terms of kind of most common usage to least common usage, at least from what I see. And this is the one that we'll be considering. There's also the second one down, which is a synset for guy. So, someone who's a cool cat is a guy. That's, I think, where that one is coming from. We can check the definition to verify. But let's stick with the first definition of what cat.n.01. Let's figure out what the definition of that first synset is. So let's go ahead and write that and give it a run and see what the definition is for this thing. So it says feline mammal, usually having thick soft fur and no ability to roar, domestic cats, wild cats. Okay, that's the type of cat I'm thinking of, so let's stick with that definition and we'll move on here. So as I mentioned, we can let's do this. Let's define a variable called cat, and that will just be the synset for cat.n.01, and then we can define the hyponyms of the types of cats. So again, if we have cat, a hyponym is something that is more specific. So for instance, in the example that we have up here, spoon is a hyponym of cutlery. So cutlery is kind of the more general term, and then as you drill down a little bit more, spoon is a hyponym to cutlery. So cat is kind of the most general term, right? And then as we keep going down a hyponym to cat, let's see what terms we get for that. So I'm going to say types of cats is equal to cat, which is the synset dot hyponyms. So I'm finding all of the words, all of the hyponyms of the word cat. So let's go ahead and loop through those and let's print them out. So what we're going to do is we're in this first loop going to loop through all of the types of cats. In the second one, we're going to loop through, sorry about that. The second one, we're going to loop through all of the lemmas in the synset that we're looking at and print out the names of each of those. So let's go ahead and run that. So again, we have cat is kind of the more general term, and as we drill down, something a bit more specific is domestic cat, house cat, some, I guess, more Latin words for what a cat could be, wild cat. So those are going to give us a little bit more specificity when it comes to a given word. So let me just comment these out there. So we can go in the reverse direction, and we can also define something called a hypernym. Let's see, I think I went down too far. Hypernym. So a hypernym I'll give the definition again according to Wikipedia. It's a word with a broad meaning that more specific words fall under, a subordinate. So for example, color is a hypernym of red. So while we had hyponym, that was going from very general to more specific. The hypernym is going to something that's more specific to something that's more general. So let's take an example of that. So I guess this is just kind of summarizing that. Sorry, I keep jumping around here. That's summarizing what I just mentioned. A hyponym drills down to more specificity, while a hyponym, man, these terms, drills down to more specificity, while hypernym goes upward towards more generality. So an example is that cat is a hypernym to house cat, while house cat is a hyponym to cat. So let's go ahead and print out the hypernyms of house cat. So remember, we got house cat from what we just ran above. So let's determine the hypernyms. And if the above example that I've written up here is correct, the hypernym for house cat should be cat. Let's just verify that is the case. Let's go ahead and give this a run. So we see that, right, so the more general term for house cat, we have the synsets of cat and also domestic animal. So these are the more broad terms for what a house cat is. So let's comment that out. So this is kind of leading up. Why do we define these hypernym and hyponym terms? Well, we want to maybe distinguish some way to determine a metric or some way to determine how similar two different words are. And one of those ways, it's not the only way, but one of those ways you can determine this type of similarity is in terms of hypernyms and hyponyms. So let's take a look at that way, and there's also a few other ways we can do that as well. And NLTK provides us a way to do this. So let's go down to this section here. All right, so let's continue on to determining how we can figure out how, given two words, how similar they are, how related they are. So one of the ways in which we can do that is based on hypernyms and hyponyms, which is what we considered above. So that's going to be the first metric in which we can distinguish how similar two words are from each other, and the function that NLTK provides to us to do that is this function called path similarity, and that will give us sort of a distance metric in terms of two different words based on the hypernym-hyponym relationships. And this value or score it's going to provide to us is going to be a value between 0 and 1, and it's going to let us know how similar or how dissimilar these two different words are. So let's go ahead and step through an example just to get a sense of how this works. So let's first determine the synsets for the word car and automobile. So I'm going to define two variables here, car, which is a synset of just car.n.01, and automobile, same thing, synset for automobile.n.0.1. So these are two different synsets, and let's go ahead and just print out the definitions of these things. So if I say wn.synset, or actually I'm sorry, let me just do this, car.definition, and then also let's do automobile.definition. So let's go ahead and see what we get here if we print out the definition of these things. So we actually get the same exact definition for both of these words. So if we print out the, let's say we print out the synset of car. So we have car and automobile. If we print out the synset of that word, so let's print out car. Let's print out car.lemonnames. That's what we want to see. So let's print out car.lemonnames as we did before. And we'll also print out automobile.lemonnames as well. We'll give this a run. And we should see a list of the words for both car and automobile that are exactly the same. So the set of synonyms for the term car is identical to the set of synonyms for the term automobile. We also see some other ones in there like auto, motor car, machine as well. So if we print out some metric that determines let's say how different two words are, how related two words are in terms of hypernyms and hyponyms, both car and automobile are sort of in the same category. So this metric that we'll use first, this path similarity metric, should give us perfect correlation between these two words. So let's verify that's actually what happens. And the way we determine how two words are related to each other in terms of this metric is we can say the first synset, in this case car, dot path similarity, which is the function, and we feed it the other synset. So if we do that, this will give us a value, and this is going to give us the score as to how related these two terms are. So we get a score of 1.0, which means that both automobile and car are identical with respect to this metric. So let's go ahead and comment that out. So let's see. So let's take another synset and see what score we get. So let's define another one, which is this word boat. So boat, let's, I guess, print out the definition of the word boat just to make sure that we know what version of this word we're actually considering. So let's print out boat.definition just to kind of give a sense of what we're dealing with here. So we'll go ahead and run that. So define the synset boat, printing out the definition, a small vessel for travel on water. Sounds about right to me. So what we can do is we can also use this path similarity function to determine how similar car and boat are to each other. So let's go ahead and do that. We're just taking the car, which is the first synset, dot path similarity, and we're feeding in the second synset boat. So let's see what score we get there. So we get a score which is quite low, which is 0.125. So you know, this isn't the only metric by which to measure how similar two different words are. Perhaps you could argue that these words are quite different. Certainly in terms of the hypernym-hyponym structure, it would take probably quite a few hops to get from one to the other, so that's why this score is relatively low. But perhaps there should be a more intuitive measure as to how similar certain words are. And indeed, NLTK does provide other measures that we can use. And actually, there's quite a few other measures that exist that going into in detail would be far beyond the scope of this video. But here are just a few: Wool-Palmer, Similarity, Resnick. There's a bunch of other similarity metrics. I don't know if NLTK provides an interface to all of these. What one that we're actually going to make use of that I know that NLTK does provide a interface for is the Wool-Palmer similarity metric. So I've also linked, at least in the write-up to this, there's a paper on which this is originally based on. It's from a paper from quite a while ago, which goes into a little bit more details on how the algorithm for determining similarity actually works. I guess here, again, that will take us a little bit beyond the scope of this video. So we're just going to make use of the Wool-Palmer similarity metric for various synsets and see what we get. So the way we do that is we just say car, which is the, remember we've defined car above here as the synset for car.n.01. So we do it in a similar way to the way that we made use of path similarity, only we replace path similarity with WUP, so Wool-Palmer similarity, and then we pass it in the other synset that we care about. So let's go ahead and make sure that we should get perfect correlation here, since car and automobile should be very closely related. So let's see what we get by this metric. So the Wool-Palmer similarity metric also gives us a measure of 1.0, so it knows that these two words are very highly correlated. So I'll go ahead and comment that out. Let's try the same thing that we did above for path similarity with boat, but let's try it against car just like we did before. So let's see what Wool-Palmer has to say about how similar car and boat are to each other. So let's go ahead and run this. So we get a value which is about 70%, which is quite a bit higher than what we saw with the path similarity metric, which was about 0.125. So this maybe makes a little bit more intuitive sense. Again, it really it depends on the metric on which you're basing how related two different words are. You could argue that both a boat and a car are methods of transport. They have similar functions. Of course, one is primarily a transport on water, the other one is on land, so this might be where that 30% or so go away in terms of, you know, why they're not one-to-one. I mean, they have obviously a lot of other differences as well, so maybe this metric might be more accurate for certain circumstances, maybe it might not be. It really depends on your requirements and your needs for whatever you happen to be doing. So I'll just keep going along here. So I guess I'm just kind of elaborating on what I said over here, that the higher number is possibly more intuitive. Let's take something even more unrelated, seemingly, and let's define a synset for the word cat. So if you recall, we printed out the definition of this synset for cat.n.01, and that was indeed a cat of the feline variety. So let's see what WooPalmer has to say about how related the word car is to the word cat. And again, similarity in terms of definition, of course. So let's go ahead and see what score WooPalmer gives to a cat and a car. How similar are they? So we have 0.32. So you would imagine that a boat is more similar to a car, but it's not as a cat and a car are less similar than a boat and a car. So that kind of makes intuitive sense. Again, it depends on using whatever metric. Really depends on your needs. So I'm just going to comment that out. I believe that's the end of this video. Again, if you want more information on the content that we covered here, there's a blog post which I'll be linking to in the description. All the code and everything, as always, is provided as well on my GitHub. So that about does it for this video. Thanks again for watching, and I'll see you in the next one. Bye-bye.